All right, everybody, welcome to day 4, Green Chili Land. Day 4, Research Rockstars Introduction to SPSS. Yeah, and it's still green chili season. You cannot drive by a grocery store they don't have somebody out roasting the chilies for you. So that's kind of cool. But anyway, glad everybody had a good weekend. We're going into day 4. This is our final day. Plans are to cover a few things today. One of them will be the checkpoint 7. That was the analysis of variance checkpoint. I want to make sure everybody feels good about that. We're going to talk a little bit about cleaning data. We've got some slides for that. We're going to create some simple charts. And again, I put the caveat in there that it is seldom that I use SPSS to create charts. I want to make sure you guys know that that's available. But odds are, if you're doing presentations, then you're going to create your charts elsewhere. But we'll talk about how you can create something and export it, say to PowerPoint, if that's something you want to do. Then we have a final review, questions and answers. So I want you guys to hit me up with some good questions. And then we've got sort of an in-class exercise to kind of wrap things up. I'll put myself on mute, give you guys a bit of time to work on that, and sort of help tie everything together, which is something we believe strongly in here at Research Rockstar. Before we get started, has anybody else taken any of the other courses that start this month? There's a factor and cluster class, and there's a questionnaire design 201. Am I going to get a chance to see you guys? Because I'm teaching both of them. They've got me really booked up this month. Oh, Lewis, excellent, taking factor and cluster. Cool. Yeah, you busiest work month of the season. Justin, I hear you, my friend. I have this salary and skills study out there that it closes on the 21st, and I am just going to be insane after that because I have to present some of the data a week and a half later at our big national sales meeting. So I understand that fact, but these classes repeat themselves 2, 3, 4 times a year, so they'll be around next year for you. All right, let's jump into day 4. Yes, we know all of that good stuff. And today we're going to talk a little about data cleaning, charts, and again, a final review. So I want you guys to feel pretty comfortable with this. It just does take practice, so that's why we've got the exercises in this particular module. And also, again, make sure you guys know that if ever you have questions, you can reach out, and I will be happy to answer this for you. So let's talk about some data analysis considerations. Let's talk about weighting data. Do you guys ever employ data weighting? Aaron says sometimes, okay. Weighted averages all the time. Okay, roger that. Lewis says, no, your data sets are too small. Well, we're going to talk about what constitutes too small here in a bit. But I do have a file that it's just an Excel file that I'll be happy to forward out to you guys. It's a really quick and easy weighting calculator. So you can create weights for things. But let's talk about why you would want to weight data. Well, very few of us have the budget to do a census. That's why we focus on surveys and sampling and things of this issue. And in many cases, there are going to be discrepancies between the survey sample and the population of interest. It is just a matter of fact. Weighting increases the effective representation. In this case, it's on genders what we're weighting on, and you can see in our sample, 60% female, 40% male. Well, the real population in the U.S., and again, we always like to look for those benchmark studies, be it from the census, the Bureau of Labor Statistics, industry groups, those kind of things that you can compare to. Even your own internal data, if you've got a data warehouse that you can compare to. But what weighting does, it helps increase the effective representation of males in this case, and brings down the representation a bit of females to kind of balance out reality. Now, by definition, weighting is again a common proactive exercise that we use to smooth over discrepancies between a target population and the sample that we collect. A data weight is basically, it's a multiplier. So if you need to increase the value or the effective response from one group and decrease in another, we're going to use our weights to do that. Need to match the census distribution for incomes, then definitely we're applying a weighting scheme. How we design that weighting scheme, I'm going to go a little bit off topic here, but generally, again, if you've got a solid, reliable benchmark to compare to, that's typically going to be the census. If you're doing, say, a consumer study, it might be a Bureau of Labor Statistics if you're doing a B2B, or it might even be your own internal marketing database. You know, if you know that 60% of your customers have purchased within the last 1 month that's in your database, then you can use those kind of figures to weight your sample to. How do we weight data? Well, we're going to use a program such as SPSS to do that for us. Now, the base module of SPSS does not create the weights for us. We have to do that. I typically do that in Excel, which is why we'll find you that sort of Excel sheet that I put together for developing weights. Before the data set, that's your unweighted. After you've created that weighting variable, the after quote-unquote data set may be weighted. Now, I do want to let you know, if you're working with weights in SPSS, every time you launch the file, let's say you closed it out yesterday and you're going back in it today, always check and make sure the weights are on if you need them to be on, or turned off if you want them to be turned off. SPSS has this interesting way of leaving the values weighted. Whether or not whenever you open the file, take a moment and check. This comes from experience working with some consumer data that I had, and you start seeing funny results. It's because the weights forgot to be turned back on. So do check that if you're working with weights every time you launch a file that you know to have weights involved. This is a nice pictorial example of how much somebody counts here. This guy on the left counts as 1. That's the guy that came in as our sample. And if we've applied a weight of 3, that means now this one guy counts as 3. So that's essentially what a weight does. If it's a positive weight, or excuse me, weight greater than 1, if it's less than 1, we're going to reduce the effectiveness of that response. Now, in common practices here in consumer research, again, we typically are going to weight on a few known variables that we can compare to based on census data. That's age, education, race, ethnicity, gender. Those are, again, common. They can easily be compared to census data, so we've got some benchmarks to compare to and adjust to. Step 1 here is identify the targets. And then we calculate the weighting factors to adjust. And that target would be, again, typically census data that we compare to. As you can see, you get most of that information from the census. Now, there are some risks involved in weighting, and this is not often addressed, but I want to make sure everybody feels clear about this. Weighting can be overused, and it can impact the quality of your data analysis. What do we mean by that? If you're using a weighted data set, it's best practice to go ahead and find out what the distribution of weights is in a data set and to be concerned if any respondent has a weight of 10 or more. If you've got a weight of 10 or more, then what you need to do is identify what that group is and go back out into the field and collect some more data. It's plain and simple. So we need to know the sample size. Yes, it's risky if we weight small sample sizes. And here we're going to talk about how small is too small. Now, Lewis, tell me about how big your data sets are in general. 200. Well, you're right at that point. You could try weighting if you're weighting on, say, a variable that has maybe 2 categories to it, gender, for example. Although the number of categories we assign to gender is changing, but still, it can take 2 for starting. If you have data sets less than 200, you definitely don't want to weight. 200 and above, it's around 200. It's your call. It's not a slam dunk idea. If you had 500 or more, it wouldn't be a problem. 400 or more, but around that 200 mark, you're sort of reaching the lower limit, if you will. And if you're waiting on a variable that has multiple categories, say more than 2, then you probably would not want to apply weights to that data set at 200. Just know the more categories you have, the more people you want to include in your sample. Now let's take a look at a customer satisfaction example. This is a good strong example here, and this refers to the real distribution as we know it to be in our marketing database. So our good friends at Acme, classified their customer database by purchase volume, low, medium, and high. And I hope by now you guys would understand that that's very subjective, and we would definitely have to have hard definitions for what low, medium, and high are. But let's assume we've got that. And Acme sent out a satisfaction to survey database, and it gets a 30% response rate. And this is the survey sample here on the left, 20, 30, and 50. And in fact, the real distribution of that database is flipped around. So low has 50. So you basically have 2.5 times the number of low purchase people in your database than you had in those that responded. And conversely, for the high side, you've got 2.5 times more. Should this be an issue? Should it be a concern? Should they care about this difference? What do you guys think? Should they care about that difference? Justice Inez says yes. What about everybody else? Aaron, Lewis, what do you think? Lewis says depends on the number. What is your N? Aaron says yes, but it's surprising to have differences. Not surprising to have differences, excuse me. Well, let's see what the scores look like. There's your top 2-box satisfaction score. So, if you were not concerned about the distribution here, what you're going to end up with is a top 2-box satisfaction score that's essentially twice what you would actually expect. So again, yes, we want to make sure we're weighting appropriately. It would be interesting to know what the top 2-box score is by group, and that's sort of what's driving this difference. I would expect that people that are high purchasers or purchase more frequently are going to be happier than the rest. So if you were to base your decision on just the sample without adjusting it, you could end up potentially making some pretty bad decisions from that. Do I need to weight my data? Fine question. Do you need data that is representative of the general population? So a Gen Pop study, and we'd measure that again against the benchmark of the census results. If that's your case, yes, you're going to want to weight things. Did you use a data collection method that could not or did not enforce specific quota distributions? So if somebody who collected your data for you, or if you did not apply quotas up front, then yes, chances are you may want to weight that data. Is over or under representation of a group a screening result? Did we screen for a particular group? Then we have to say, maybe I don't necessarily need to weight my data there. Do you have a small sample size? Let's say less than 200. Then weighting can wildly skew your data. So there's some definitely good reasons to weight your data, and there's some reasons where, again, if you've set it up as a measure of a screener, a quota, for example, or if you've got really small data sample sizes, then you wouldn't necessarily want to weight your data. The caveats and cautions here. Only weight your data when you know what the target data should look like. So if you've gone out and downloaded the census data for age, for example, or age by gender, then you know what the target data should look like. Then you can create weights according to that. I think the most complicated weighting scheme I've ever had to develop was one for 3 variables. Easy enough, it's simple for 1, it's a little bit more complicated for 2, but to get into 3 you have to make some assumptions, and that's where it does get to be a bit challenging. SPSS does have a tool, it's an added module though, that will help you with this more complex sampling. We don't want to weight data when we're working with small data sets, again, less than 200. Avoid weighting factors of 10 or more. Okay, go back out and get more data if that is the case. Working with outside research suppliers, you need to ask them if the data is weighted, and if so, what items did they use to make those calculations. So know who your target are, and know what that distribution looks like. If you've got small data sets, pass on weighting, and pass on weighting if you've got factors of 10 or more. And if you're working with outside suppliers, ask them, check in with them, and say, hey, did you guys weight the data? If so, on what variables? Talk about cleaning data now. So that was weighting data, very important to consider, particularly if you don't set quotas up front. So let's talk about cleaning data. This is less of an issue now that we're working with online data collection tools. It used to be far more of an issue when you had people manually keying in data for you. Because you're keying in data and you're flying down pretty fast, you might hit some wrong numbers and things like that, so you would always have to go in and check the data, the quality of that data entry. In this case, even though we're working with an online platform, survey data can be dirty, and we will need to take some time to clean it. Before we get into this car budget, I can tell you that my salary and skills study is a really good example of that. I'll have, if I'm lucky, 14 to maybe 18,000 respondents. And not all of the respondents will make it through the entire survey. Some will bail out early. So I have to go in and figure out, first of all, what do I want to do with those folks? How much of the data do I want to keep, if any? Fortunately, Qualtrics tells me, if somebody's made it through 100% of the survey. Next step is, if you've got, just from an SPSS standpoint, platforms like Qualtrics, Cvent, and I'm going to harbor most survey platforms that can export out to SPSS, will try to put the entire question in the variable label, and it will put whatever the extent of your value labels are in the survey. And that may be just too much information, so you may need to go through and clean that out, for example. It just makes for easier and better reading of the output that you have if you've gone through and tightened things up. Again, the rule of thumb that I use when it comes to value and variable labels is keep them short and succinct, but give enough information so that somebody who doesn't have the survey in front of them can still have a good understanding of what it is you're presenting. So that data cleaning process, by the way, you should budget time for. If you have open ends that you are having somebody else code for you, that would take some time and possibly money as well to budget for. Other data cleaning would be if you have numeric variables that are open, such as income. In the salary study, I asked people what their income is for last year, or if they had a bonus, what their bonus amount was. Since this is a global study, I had to determine last year if I was going to go out and employ a salary calculator or a money converter, if you will. And this year in the survey, I simply put that link in there. However, people will still, somebody will have missed that and put in that they earned 20,000 rupees. So I have to go in and decide if I want to clean that up. So anyway, data cleaning, what I'm trying to get to here is budget time for it. There may be some physical expense as well, but certainly give yourself some time to do that. Example we have here is a car budget. And again, this is an open numeric. We had somebody input their car budget that they were willing to spend. On the left, you've got people, let's say $30 or less. These are definite outliers. You've got on the other end, 170,000, 2.99 million, definitely outliers. The bulk are falling here in the middle, and this is what you might expect to pay for a new car. You've got some on the high end. These people are going to buy maybe a sports car, or a brand new four-wheel drive pickup truck. But really, folks over here on the left, say less than 20,000, you may consider to be outliers. So how do we clean our data? We talked a little bit about this in day one, I believe, but we're going to come back to it again because it is a critical issue and it can certainly impact your data, particularly if you're working with, say, marketing data warehouse, data that's coming from a data warehouse, where not everybody may have all the variables nice and neat and filled out and complete. Less of an issue in surveys, but still, definitely an area that we have to take some time to look at. So step one, we want to diagnose. What's our diagnosis? We want to identify suspicious records. We're going to be looking for outliers. Again, an example that we had here, in an open-ended question about how many books someone has read in the past 30 days, somebody enters 53. I don't know about you guys, but that means they're pretty much reading all the time and not sleeping. So that would be a potential outlier there. Example, an open-ended question about planned budget for new car. Answers range from $1 up to 3.5 million. So we have to look through these open-ended responses. We have to determine what to do with those. One of the most common areas for cleaning is missing data. Now again, there's different types of missing data, and before we go on to the next couple of slides, I want to run through these ideas first. If you have set up survey logic, right, where only, say, a purchaser of your product is going to be seeing certain questions, then everybody else in your data set that is not a purchaser, you'll have what's known as system missing data in SPSS. It means it's by logic and by design that they did not see a question. Therefore, they don't have any data for that question. Now, it's fine and dandy to leave system missing data as it is. If you're looking at frequency counts, people with system missing data will be taken out of the analysis, and that's where you get the valid percent. The valid percent takes out all system missing data and recalculates the percentage distributions. But there may come a time when you may want people that would be system missing. You may want to incorporate them in other analysis. So you give them a variable that's way out of range, 99, minus 99. And that way it brings them into the analysis, and you can actually look at those people and better understand who they are. Other missing data, and here's a good example. In survey on cameras, several respondents have missing data on the question on likelihood to purchase in the next 3 months. Let me ask you guys this. When you are creating surveys or you have surveys created for you, do you know if they make the questions required? Do they put that requirement that they have to be answered? Yeah, again, it's very, very common to do that and just sort of require people to respond. The example that I would use where that may not be the case would be for open-ended questions. If it's part of a process such as like a form where you need somebody's name or email address, then yes, make that required data. If it is something along the lines of at the end of the survey you're asking somebody if there are any other thoughts that they had, then make that not required. Because they may or may not have thoughts at that point about the survey item in hand. Now, Aaron, you said OEs, open ends, are where I sometimes don't require it also. Completely agree. If it's part of a sales qualifying survey, then you have to have name, you have to have contact information. That should be required. If you're talking about a net promoter score and you want to have people in the three groups of net promoter, the detractors, the passives, and the promoters, you want to have them answer a question about why they responded that way. Then, yeah, consider that to be a required question. Okay, thank you for that digression here. Let's talk a little bit more about missing data. You've got these folks that did not answer likelihood to purchase the next 3 months. So what are we going to do with these people? What might this mean? Well, let me back that up for a quick second here. What might this mean if they didn't respond? Now, again, we've talked a little bit about in this course. I talk more about it in the survey design course. You want to make sure that you have a category that everybody can respond to. And if you have missing data to a question, it may mean that they don't have a category that they could respond to, or that those categories may be overlapping, and the respondent might not know which category to select. So some of this missing data may be a function of how we design the survey in the first place. Okay, so several respondents skip question 617. Do we delete their records? That's certainly an option. Do we treat it as missing data but use the rest of their data? That's option number 2. Do we create estimates behind door number 3? Now, when it comes to missing data, and I can tell you this exactly when I had when we were getting our salary and skill study ready, I was working with a copywriter to kind of clean things up, and first thing she asked, she says, "Do you have last year's distribution? Do we know what questions people were bailing out on? What was the last question they answered?" Essentially, some platforms will give you that data. We can prevent a lot of this, however, by doing a pretest. That's one of the advantages of taking the time to do pretest, is you can see where people are exiting the survey. Then you can go back and look at that question and those categories and make sure they're appropriate. Make sure you didn't forget anything. Now, on the other hand, SAS and SPSS and other platforms do have techniques for creating estimates. Do you guys do any work with missing data? Do you employ estimates? Do you delete the records? How do you guys handle that data in your current work? Lewis uses upper and lower limits. Okay. Good bounds. Aaron, usually if I have missing data, it's because there was a skip, so I just use the rest of their data. Okay, again, perfectly, both of those are perfect examples. Let me see. Justin, what do you guys do if you have missing data? When it comes to missing data, there are, again, you can, not working with large data sets, okay, day-to-day, so everybody that responds to your survey does so in a full and complete process. You are a lucky man in that regard. What do we do? Well, you can use any one of these methods. You can use some of these methods in combination. When it comes to open-ended data such as income, or purchase data, another good example, you can use estimates. Simple to use mean or median. Little bit better if you can identify some other variables. So if you've got a particular respondent that fits a particular group, or as part of that you can profile, you can always take a look at people in that group and see what their median or mean income is, and then use that. It's a better method than taking and applying a global mean or median to it. So anytime you can take a respondent and bring them on down to a group level and take a look at those people that are also part of that group that have the data that's complete, and use that as a starting point. Okay, missing data is important. The other option obviously would be to throw people out, but if you've only got 200 records, you start throwing people out, then that could become an issue in itself. Treating it as missing data but using the rest of the data, very common approach. Certainly allows you to maximize the amount of data that you've collected. So I typically use some kind of mixture of these last two, where I take the estimates or take the data that they have, and then if I really need them in the model, I'll create estimates. Let's talk about data reliability. How do we know if our data is reliable? This is a question that not the easiest one to answer, but one that we have to be prepared to discuss at some level. Hey, here's a simple formula for sample size. N, your sample size, is a function of variability, essentially. It's not the population size. This is how 2,000 people, give or take, can give you a reliable estimate on a national sample in the U.S. Now, what you have to keep in mind, though, is that, again, this is where you have to tie your data analysis goals. If you want to start cutting data by region, by gender, by age, by some combination thereof, then you're going to need more people. If you're looking at raw frequency counts and making an assessment based off those alone, then you're okay. It's when you want to start slicing into the data that you need a greater sample size. Aha, eggs and shampoo. Used to be milk and shampoo, so they've changed this one up on me a little bit. Which of these two, if you were to go into a grocery store, and which of these two, if you were doing a research project around grocery purchases, I should say, and which of these two product categories would you need a larger sample size for? Shampoo, says Lewis. Lewis because of larger variety. Aaron, Justin, wouldn't it be the same? No, Aaron, that's a good question, but we're going to take a look at it why it wouldn't be. Justin, what's your thought there? Which would you need a greater sample size? Not sure. No worries. Well, that's what we're going to talk about here. Eggs versus shampoo. Yep. Let me come on back here then. I thought there was another one to that. Let's think about this. If you go into the dairy aisle and you're looking for eggs, how many different options might you have? You might have size options, a small container of 6, 12, or 18. Okay, so that's one variable with 3 levels to it. You might have brown or white. Okay, that's 2 variables. You might have organic versus non-organic, so that's another variable. What else would you have? Size of the egg. Small, medium, large, extra large, jumbo, whatever they may be. Even with all of those, that's, 5 or 6 variables maybe, there's less variation in eggs than there is in shampoo. If you go down the shampoo aisle, you can it's a much longer aisle, first of all. And that's because there's more brands, there's more additives, there's more sizes, there's more price points. There's just a lot more variation in the shampoo aisle than there will ever be in the egg aisle or milk, as we used to do in the previous versions of this course was milk. But either of those food categories, compared to shampoo, shampoo would definitely have, because it has much more in the way of variation. Now, if you're talking about frozen food versus shampoo, then you might slide it towards frozen food, because there's even more variations there. I mean, just think about the amount of aisle space, excuse me, as a measure of variation the more aisle space you have dedicated to a product category, the more variation you're going to have, therefore the greater the sample size. So, two things that I want you guys to think about when saying reliability, talking about data reliability, is what is your sample size? How many people do you have? That's typically the easiest measure. You know you're going to need more people if you're dealing in a product category or service category that has a lot of variation to it. How could we use the sample size formula for this example, egg and shampoo? It is going to be down here as a measure of H. That's your variation. Numbers to plug in. You can always adjust this. I mean, there are some benchmarks that we could employ, and we're not really going to get into. I could teach you a whole day-long class on sampling. It can become incredibly complex. But typically, if we go out to sample calculator, and there are plenty of good ones out there online, if you start off with more variation, and to be honest, the biggest sample size is going to come if you're looking at, say, a population with 50-50. 50% male, 50% female. If the greater the difference between that, the smaller the sample size that you need. But when things are 50-50 coin flip, you're going to need more people to do that. So in this case, tying it back to the egg versus shampoo, that comes down as a measure of variance over here. So the greater the variance, the more people you're going to need. I don't have any good examples of dropping actual numbers in to create that. But what I would suggest, and I can do this, I can go out and find a couple of sample size calculators, and I'll forward you a link to that. And those are pretty simple in the sense that you simply punch in the estimated percentage and the willingness, the confidence interval that you're looking for. Again, this is one of several different versions of sample size formulas. So there are a couple of others that are actually a little bit easier than this. So anyway, I don't want to get hung up on that, but what I will do is I will get you guys two things. I'm going to send you a weighting calculator, and I'll send you a couple of links to sample size calculators. Okay. These are the things that we've talked about, and we talked about importing data, and now we're all the way down here to creating charts in SPSS. Let me ask you this. Do you guys use presently in the work that you're doing SPSS for creating any charts? Yeah, it's Excel is definitely better, and I can tell you that charting has become better in SPSS, and but it is still very, very limited. So hang on, give me just a second. I will pull this up. Okay. Now don't forget, you guys can use the full screen mode if you need to. Make things a little bit easier. Oh, okay. Let's talk about creating graphs. Again, I create graphs in SPSS if I just need a good, quick visual. And typically, we can do that in a couple of ways. Let me come up to talking about frequency counts. That's really a good place to start. So let's go ahead and take this particular variable, and let's take maybe the first 4 or 5. Now, as we recall from day one, you can set statistics, right? That's important when looking at variables that are numeric in nature. You can set a format, but here you can also set charts. And again, this is sort of the basic chart within SPSS. You can set things to be a bar chart, pie chart, histograms, and we're going to do bar charts in this case. Now you can tell it to give me frequencies or percentages. Let's do frequencies and hit OK. And it gives you the tables first, and then if you scroll down, you'll see a series of charts here. And again, this is just a good way to get a quick visual. I would not base any significant analysis off this. I would not necessarily copy and export these charts, although you can. And let me show you how you do that. You click on that chart, you right click, and you can say export. Okay. Now you can export everything, all that's visible, or only the thing that you've selected. So in this case, we're going to just simply export this one particular graph. You do have to give it a name and where you want it to go. Okay, you do get a chance to select from a variety of different documents. You can take this one graph and create a PDF with it. You can create a standalone PowerPoint with it. You can export it to Excel, not sure why. To HTML, to web reporting, you've got options there. Plain text, you can ship it out as a Word document. So you've got options there. And then you would simply, again, browse, point it to where you want it to go, and hit OK. The other option is you can, if you've already got a PowerPoint set up, you can say copy special and simply tell it I want to copy it as an image or a JPEG and hit OK. And then you would be able to go back over to your program, PowerPoint, Word, InDesign, whatever you're using there, and paste that in. So that is one option, and you can see as we scroll on down, you can see this is almost a normally distributed curve. Let me show you another variable here. So let me come back to frequencies. Let's reset. Let's scroll on down and find our income. That's X35, I do believe. Now X35 is income. You can right click, get variable information, and find out, yes, it's income. So we want that particular variable. Now here it might be interesting to run statistics because again, this is a metric variable. So let's go ahead and get quartiles, mean, median, and let's also do a chart on that one. And let's do a histogram and show normal curve. So what a histogram does is it simply takes an open numeric variable like this and creates buckets for it based on the width of the distribution of the data, and then puts a curve on top of that, a normal curve, if you will. And this becomes important if you are wanting to do a deeper level of analysis, such as regression on your data. One of the key assumptions around regression analysis is that the data is normally distributed, and this will come back and help us assess that. So we hit continue, and remember from formatting frequency counts, if you've got a lot of open-ended data, as we would expect in an income variable, we can suppress those tables so we don't get this lengthy table. Okay, so it ran through this one fairly quickly, and looking at again at this table, it tells you have 405 records. None have missing data. You can just see what the mean is, the median would be, the percentiles, so forth. It also gives you that information here to the right side of the graph, and you can see that things do not particularly look normally distributed, mainly because we've got these long tail people out here. These are our outliers that we talked about earlier. So that's, again, this is just very simple usage of graphing within SPSS. Let me show you another. Let's see, let's come back to, I do believe it is Explorer. Yes, Explorer will do it. So let's take our variable here. The factor, that's the variable that determines or isolates which restaurant they went to. Let's take our income variable again. And we can add other variables. Let's take children and add that to the factor list as well. The factors, if you will, are those variables that we're going to be sort of cutting the data by. The dependent list is the numeric data that we're going to be parsing out. Let's do statistics. Let's do M estimators, outliers, percentiles. Let's take all of those. But I also want to do some plots in this case. And in this case, I want to do, let's do histogram. I'm not a great fan of stem and leaf. Some people are, but histogram with a normality plot is going to be good. So let's continue, and let's hit OK. So again, you might remember from previous days, this is sort of the Explorer procedure, the descriptive statistics that we get, and you can look visually and see, hey, the average data for these two restaurant patrons is quite significant. Let's see, you've got your estimators, various different ways of estimating the mean. You've got percentiles, and you've got extreme values. These are our outliers. And down below all of that, we've got our graphs. This test of normality does tell us that the data is not normally distributed, by the way. Okay, so we didn't get normality plot. Oh, okay. In this case, we get a histogram, but it doesn't put the normal curve on top of it. We could get that via frequencies if we needed to. But what you do get are these plots here. This is a normality plot. It is, unfortunately, not normally distributed. If it were, these little circles would pretty much approximate this line from start to finish. So it is more so for this first group, which I think is Alberto's. This may be Tex-Mex Grill. Excuse me, that's for no children. That's right, we did two variables. You can see for no children, definitely not normally distributed. So again, what I'm showing you here are just some basic charting procedures that are part of other functions within SPSS. Frequencies will give you charts. The Explorer procedure will give you charts as well. Regression, as an example, will give you some charts of the output. You can test a lot of the assumptions around regression based on some of the charting that comes out of the regression module. But if you wish to build a graph on your own, there are some ways to do it. You do have graphs over here to the right of Analyze, and we have a couple of things. We have all of these legacy dialogues, which are now picked up in the chart builder. So let's take a look at chart builder here. It's not the most intuitive charting that you'll find, but you can take and drag variables over. And come on. Oh, I've got to pick a chart first. There we go. Let's take a bar chart, drag that over, and let's put this guy on the X. And again, we have a very simple bar chart. Like we had, we can change variables. We can change to percentage, and we can hit apply and OK. And this is going to give us basically the same graph that we saw under frequencies, just a little bit different in the sense that we've added percents here. Now we can double click on the graph, and what that does is it brings up the chart editor. We can you can change the size of you got properties box here, so we can change the size. We can change the variables that we're using. We should be able to change the color of the fill, if I'm not mistaken, like that. And you can double click on things like the percents, the numerics, change that around, change the font around, size, color, etc. Now, there are certain charts. We're not going to get into the concept of perceptual mapping too deeply here today, but there are some specialty graphing options available when working with techniques such as perceptual mapping, which is wonderful for market positioning and competitive analysis. And in those cases, you can come in and take the charts that they create, that those procedures create, and change where the zero axis is. You can adjust things so the chart looks cleaner and clearer to understand. But we're not going to, again, that's more of an advanced technique, so we're not really going to dive too deeply into that today. So anyway, we've just changed the color. You can export this, like we said. You can copy it using copy special. One simply creates a file, the other one simply creates something that you can drag and drop. Okay, let me see if I want to go into any other options here. Let's take XS4. That defines, this is comparing subgroups. I've not actually worked with them. So we're going to do this on the fly. Let's take all of our original 11 variables that we were working with and plot those out. Cases are sorted by subgroup variable. No, they are not. Okay, options. Again, options on the graphing allows you simply to change the size, change various techniques and things like that within the graph, options within the graph, such as color and font size. Okay, so it's running, still running. Okay, whoa. What happened here? Kick me back over there. Okay. Hey, this is an interesting one here. This takes a look at apparently all of those variables and plots them against each other. Now, I don't know what these lines are. Interesting. Again, this is something I've not used, but there are some methods to plot multiple variables like this onto a single graph. If you want to get a quick read. I'm wondering if that is, my guess is the purple is the actual group. In this case, Alberto's, for example, for question 7. And this one here is probably going to be the, yeah, looks like it's an overall. So it looks like in these graphs what you're doing is you're comparing over your particular subgroup to overall. So see if we've got any other interesting things here. Not really going to get into the graph board template chooser, mainly because it is your graphs in PowerPoint will be more effective, I think. Okay. Whew. Let me take a quick breather here. We're at the top of the hour. We've got about an hour to go. So a couple things I want to do is I want to go back and look at everybody's exercise for the last PowerPoint, or excuse me, last PowerPoint. Checkpoint. That would be checkpoint 7. Did everybody have a chance to get through checkpoint 7? Okay, Lewis got through it. Excellent. Justin, 50 lashes with a wet noodle. That's okay, my friend. We're going to, okay. So for Lewis and Aaron, did you guys have any issues with it? Did it come through? Did it seem reasonable? Were you able to tell a good story? Did show Alberto's or Tex-Mex grill in the output. Okay. Did not show. Interesting. Okay. That is odd. Sure, clear on the interpretation. Okay. Let me take a look at this one real quick. Pair means, one-way analysis variance. Okay, cambiemos abiertos. Okay. Okay, so here we are. Keep in mind analysis events. Always look, for some reason, this particular exercise always makes me go, did I write this right? Requires 3 more categorical groups. Okay, go to 1. Okay, that's odd. Okay. It's one of those days. It's a Monday. Okay, so the interpretation on this would be, let me go ahead and run that data for us. Let me first of all clear up some of this, get this stuff out of the way. So you guys know, I want to make sure I throw this out there. If you hold your control key down, you can click on and highlight several things and then hit delete. If you want to clear up your output, it's one way to do it. I do like to try to keep these things relatively clean and simple to read. And again, all your logs are if you've run a procedure, everything from frequencies to things that are more complicated, your log tells you what you have done. This is essentially the program that if you were to do this from a programming standpoint, what it would be. So let me go ahead and delete these guys. Let me come back over here to my window and make sure I've got all of these scales created. And I do, but I want to give them some decimal points. Okay. Okay, so we've created several new scales actually. And we want to do something, we want to compare Alberto's to Tex-Mex on the 4 lifestyle scales via one-way analysis of variance. And I'm sitting here thinking, why would I want, this would have been better served as a t-test. Anyway, let me run them as t-tests. And I know what I wanted to do. Yeah, the reason, again, I apologize, this always kind of steps me back and says, how do I write this and how does it make sense? What we want to do, since it didn't include Alberto's to Tex-Mex, it was difficult to answer the questions. Okay, let me come up here real quick. As long as you've got this, you should have Tex-Mex. But what I'm actually wanting you to do here, and I think I need to kind of go back and touch this particular checkpoint up, is to select the particular restaurant. So let's do that. Let's walk through this real time. So I want to select a case, and I want to select a particular restaurant. So let's take our restaurant variable equals 0. So we're going to focus on Alberto's first. Now there are variables in here. Let's come back over to there's variables in here that we're going to compare that are metric. All of these scaled variables would be ones that we would want to compare. Now again, keep in mind, we've selected Alberto's patrons only at this point. So what I want to know then is I want to know if we're looking at within Alberto's, are there variables that have 3 or more categories? Number of children does. Obviously income by quartile does. So let's take a look at that variable in particular. I'll run an analysis of variance off income. So let's take income. Remember, we created the quartiles, we created the 4 break points within income, so we're going to take that as my factor. And then we're going to take some of these scaled variables. So basically what we're doing here do post hoc, let's do Bonferroni, that's fine. And let's create descriptives and means plots. So what you know is you've already pre-selected a particular group. And again, you can come back in here and say one way and type in Tex-Mex. Or excuse me, is Albertus, if I'm not mistaken. There we go. You can always add some additional content you're labeling there. And all we've done here is created a sort of a profile for Alberta's restaurant patrons only. Now we would go back after we've gotten everything we wanted to run here and come back and do the same thing for Tex-Mex Grill patrons. So just this is a bit of a deeper dive. And let's take a look at the self-confidence scale, for example. And see, you can see here at the initial point, these two income groups, the scores are really flat. It begins to take off when you get into higher income points. So we have to come back over here and say, does that make sense statistically? So we simply scroll down to self-confident. And it looks like, my guess here is we don't have enough people in each of these groups for this to really be meaningfully full significant. Careful about what they eat, however. Let's take a look at that. Okay, that's got an interesting trend to it. So if you come back to the multiple comparisons, does that red arrow mean anything? Let's see. Which red arrow? Let's try careful about what I eat. No, that's okay. The red arrow to the left. Gotcha. That just simply means that's the graph that we've clicked on that we're looking at. And that shifts. So this red arrow to the left, Lewis, simply means that's what you've highlighted this particular graph or table, and it just reminds you that's the one you're actually looking at. So if you were to come up here and say, for Alberta's patrons, the concern about what they eat declines with income. I would have thought it would have gone the other way. But in this case, it declines with income. So higher income patrons are less concerned about what they eat. Makes good sense to me, at least from the standpoint of the fact that traditional Mexican food, again, is very heavy, not what you would consider necessarily healthy conscious. Grilled food tends to have a greater consciousness associated with it for healthy eating. So we could certainly run this for Tex-Mex and see if that makes any differences as well. Basically, the gist of this task was to kind of go in and look at sort of a deeper dive, patrons for each of the two restaurants. The analysis of various component here would be, again, if you've got variables, you've selected a particular restaurant, and then you've got variables which have more than two categories. Then you would say, okay, that's a setup for an analysis of variance. So, okay, that being said, let's go into, I'm going to switch out of this here real quick. 1 second here. We're going to come back over here, and I want to bring up the workbook. We're going to take a look at this exercise I'd like us to work through. It sort of summarizes things. Take reviews, pull that out. And then I want to do a question and answer. So we're going to do Q&A, I guess. We'll do some Q&A before, and then we're going to dive into this one. Is that the one I want? No, actually, that is not the one I want. 1 second here. And these should be loaded up on the portal as well. Actually, no, this is the one I want. Okay, my apologies. Customer profiling. again, one of the things that's critical anytime we have survey data like this is we look at how can we parse the data, what kind of groups can we create to facilitate meaningful analysis and ultimately storytelling, if you will. And in this case, I think we took Tex-Mex Grills customers, and the final exercise here is we're going to take a look at these guys just for Tex-Mex. So we're going to do a select if, select cases, Tex-Mex. Want to know what their dining habits are, opinions about themselves, and what's important to them in a restaurant, and any notable demographics. So again, this would be, if we're writing up their final report and we're talking to Tex-Mex, the owner of Tex-Mex Grill, he's our client, he's going to want to know who his customers are. What do they look like? This is how we would get to that kind of answer for him or her. So we're going to take the lifestyle scales that we created. We're going to take a look at, and we're going to say, how do those Tex-Mex customers view themselves from a lifestyle perspective? How do they rate Tex-Mex Grill on the key attributes, that is X12 to 21? Are they satisfied, likely to recommend? I believe we created a variable for dining frequency. What's important to them in a restaurant, and this is the X26 to 29, that was the ranking exercise. And what do they look like demographically? Age, gender, children, income. So that's step one. And I want to make sure this is in the portal, Tony, that they can download. Okay. Why don't you guys go ahead and download this? Take a moment and do that first. Okay, thank you, Tony. Go ahead and download this, and because you want to have this available as while you're working on SPSS. I'm going to put myself on mute and give you guys about 25-30 minutes to work on this. I'll be available to answer your questions in chat. But essentially, what we're going to do here, the purpose of this exercise is it ties a lot of things together, and it would give you the ability to tell a story to the Tex-Mex Grill owner or their marketing director, whoever your end client might be. Okay, so you guys can download this from the file pod here, and do that first, and launch SPSS, and I will be available via chat. And let's come together at about 30 minutes, about 40 minutes to the hour. If you guys are done sooner, then you can raise your hand there and let me know. We can come back earlier. But again, this final exercise kind of ties everything together. Ask questions in chat if you need to. And let's give that a go. So we'll see you guys in about a half an hour. Ask questions if you need to. I am here. And we'll talk about this exercise when we come back at about 12:40. on that. I know there were some issues, and I want to address those before we wrap things up today. So let's take a look at a couple of things. I am going to pull SPSS back up real quick. So let me hide this guy. And I'll pull SPSS back around. And one of the key points of this exercise, obviously, is to kind of re-solidify your hands-on experience, your muscle memory, if you will, of SPSS. But I also want you guys to start thinking about, if you don't already do this, I should say, is think about the data that you have and how you can use it to your advantage, the kind of questions you should be asking yourself about the data, or asking of the data, I should say, and the kind of questions, kind of answers that the data will provide back to you. So let me come over here to the variable side. And the first thing we wanted to do was to kind of narrow down a particular subgroup and see what they look like. Now, we could do that a couple of ways. We could certainly go to the data, select cases, not a problem there. Or we could simply, let me go out there and let me take all cases. So that's under data, drop down to select cases. This is how we can specify a subgroup that we want to look into. Here we're just going to take everybody, and we're going to start doing a few things just via the crosstabs and t-tests. Look at things that way. Now, one of the reasons I wanted you to kind of do a subgroup is some of these models and some of these procedures, if you will, do work better when you've isolated the subgroup of interest. But we can certainly take a look at these side by side. So let's just start off with doing some an independent samples t-test, because we know that there's two types of restaurants, respondents that we had. Okay. Continue. Let me bring that up real quick here. This cut point, just as a reminder, if we wanted to look at income, irregardless of restaurant, then, and we know the median's 60,000, we could put that cut point in there and say, let's look at what people think when based only on income, not necessarily what restaurant they went to. So that's where cut point would come into handy. And let's take a look at these variables here. Let's just run them all the way down through X25. Options, again on a t-test, 95% confidence interval. Since we're only dealing with 405 people, let's just leave the defaults as they are and hit OK. So this will give us the basis for a profile for all of the metric variables that we were looking at least on the attitudes and opinions. Let's now come back up, and I think we had banner tables. Let's take a look at banner tables for these guys. So custom tables, again, if you have the tables menu or module added on, you could do this. Otherwise, we could do it in crosstabs. Pardon my computer, it's working really hard for a Monday here and taking its own time. There we go. You know, when you put a banner together, best thing to do is to put the variables that you want to look at, the subgroups, put that in the columns. Okay, it's typically the easiest way to go about it. With this case, we've got just two columns. So let's go ahead and hit summary statistics. And let's hit column percentage, because that's really what we're testing. We're looking at the percentages. I don't really need count so much. I know we've got about 405 people. I'm not going to worry about that so much. So we will take column percentage, and I want to create a total. So I have the ability to look at Alberto's, Tex-Mex, and overall. Okay, so let's take a look at that. Let's come down to some of these questions. These are the rank order. Okay, so let's take a look at those. We'll just highlight those, drag and drop. Now I do like to put a total in for the variables that I do. Categories, totals, select total. 30 was less than, that's I think distance to the restaurant. And let's give that a total as well. Let's take a look at male, female. Let's take a look at all of these as well. And one thing you can do, as you notice, when you bring multiple variables over, as long as they're highlighted, you can come down to totals, so you don't have to do them one variable at a time. And I think children was the last one. Oh no, we do have number of children. And we could take a look at income. Let's just take a look at the quartiles there. Okay. Now that's all the variables we're going to be looking at and building out in this table. I do want to test some statistics. I want to know. So we come over to the Test Statistics tab, compare column proportions, and tests of independence. So if we're looking at categorical data, which we have here, compare column proportions and tests of independence. You can also run a t-test as well, but we don't really have any metric data to compare. So then let's hit OK. And this is going to build out a very large banner table for us. Certainly not the largest you'll ever see, but so you can see we have the column percentages for Tex-Mex and Alberto's and overall. Quickly scanning down, you can see if Tex-Mex Grill is your customer, they're most concerned about food quality and service. The atmosphere and the price tend to fall down. By comparison, Alberto's respondents are concerned about two things. Price, well, really three when you think about it. Price and food quality rank up towards the top, following closely behind is service. So definitely what's important to them in a restaurant is different. And this is the kind of story that we could, really good foundational efforts for a story here. How about distance to a restaurant? Again, just scrolling down quickly. You can see that Tex-Mex Grill, a greater percentage of Tex-Mex respondents live close to the restaurant. You got 34% versus 20%. How about ad recall? Ooh, not so good here. So this is a measure of your marketing effectiveness. Can they recall their ads? 82% of Tex-Mex Grill respondents could not recall an ad. So that's feedback to the advertising team. How about gender? Well, you know, you've got more of an even distribution. Both skew male. And again, this is an area where we may have used a quota to adjust this. We may use weights on the back end if we happen to know the gender distribution for the market area that we're looking at to adjust this. But suffice it to say, respondents for Tex-Mex Grill are more than twice as likely to not be able to recall an ad. I think it's 82% versus 41%. So from a gender perspective, again, Tex-Mex Grill tends to draw a greater percentage of males. Number of children, again, substantially greater percentage of Tex-Mex Grill respondents without any children, over half. So again, the story you might want to tell, if you are Alberto's, your respondents are price conscious, right? But food quality is also important, so you cannot sacrifice food quality for price. You have to try to manage that in both ways. Income is definitely different. You've got a greater income for Alberto's patrons than you do Tex-Mex Grill. Looking at the chi-square, you can see just about everything is, well, everything is significant. So the last part of the exercise, so we can see we've definitely got some differences here. But the last part of the exercise I asked for, step 2, is where would you go from here? What kind of, we can get down to 2 levels here fairly easily. But where would you guys want to go if you could continue to analyze this data? If you were building out a profile. Well, while Aaron's working on that, I want to say you can come back up here at the basic banner tables. So Aaron says, I thought it would be interesting to look at the infrequent patrons to see what their perceptions are relative to frequent patrons. This would help us see what to improve to get them to come more often. That is a perfect line of thinking, Aaron. You generally want to say, I don't think I have frequency in here. Let me add frequency here. I don't know if I created a frequency variable. That being said, I would definitely agree with you that frequency. Take a look at the percentage of infrequent versus frequent diners for the restaurant that's your customer, and probe that a little bit more deeply. Are they infrequent because they have lower incomes? Are they infrequent because they live farther away? So good line of thinking there. This data, again, we can go as deep as we have number of respondents to dive into. So we don't have too many more. We can go down a second or third level. In fact, while I've got about 9 minutes to go, I will do up that frequency variable, and we'll just take a quick look at those. Let's see, so it's x25. So 1 and 2. Okay, so let me do this. So I'm going to recode into a different variable, x25. We'll call this frequency. Okay, so let's change that. Okay, I think 1 and 2 were infrequent. I'll put those at the bottom of the list. 3 was, I think, sort of in the middle, the occasional diner, if you will. Let's put them in the middle, keep them there. And all other values I want to be at the top, because we know those are our frequent diners. Continue, boom, okay. Now just keep in mind SPSS always adds variables to the bottom. Frequent. 2 is occasional. And 3 was infrequent. Now let's come back to that table and let's add that frequency variable to it. Put him right at the top. Let's add a total. Let's run that again. There we go. 55% of Alberto's patrons are frequent. Look at this here at the bottom. 44% of Tex-Mex Grill. So that is the concern here. That's the group that you want to focus on trying to move up to infrequent, or at least to occasional, and then hopefully up to frequent. So to find out who more about these Tex-Mex Grill patrons that are infrequent, that's where we would select cases and focus solely on Tex-Mex Grill. So what else can we do? Any other questions about anything we've covered? Because we've got about 5 minutes here. If you can't think of a question today, feel free again to shoot me a note through the portal, and I will get back to you via email. But I do want to say it's been a pleasure working with you guys. I do appreciate it. I will see you again soon, I hope, in other classes. But any questions about things we've covered a lot. I do encourage you to go back and review the recordings and just play with the data. Oh, yeah. If you're only accustomed to using Excel, then, Excel is great. I still use Excel frequently. But my go-to program, and if there was a program that I can honestly say has defined my career, it has been SPSS. I learned to use it when I was an undergrad. I basically paid for my grad school using it, and it has been a staple everywhere I've gone since then. So it's a good program. What I can say is continue to play around with it. There are some good videos out on YouTube as well that cover different areas of SPSS. Some things I think that I would like to cover perhaps in a second level class would be when to use non-parametric tests. That's these guys down here at the bottom. Maybe a little bit more about multiple response, how to set that up, how to employ that data as in a sequence, if you will. Multiple response first, then perhaps a rank order second using that data. So there's some things there I'd like to go back over. If you're going to be around in factor and cluster, we're going to be hanging out in classify and dimension reduction. So that's where we'll start there. Thank you both, and Justin, wherever you got off to, thank you as well. And will it cover multiple regression or two-way or three-way ANOVA? Wow. Dude, right on. In SPSS 2.0, if I build out that class and I've pitched it to Catherine, we would definitely look at regression, multiple way ANOVA, probably two-way. Three-way gets to be a bit more complicated than most people can digest. I would probably work in some things around more about dimension reduction and classification as well, discriminant analysis, and probably tree analysis too. I love working with shade trees, cart trees, things like that. So I bid you all adieu. I'm going to give you back 3 minutes of your time. Thank you so very much. You guys have been great. Keep playing with it, and by all means, if you have any questions as they come up, shoot them and I will get back to them as quick as I can. So thank you guys very much.